Hey, hello guys, how you doing? So today we are gonna discuss about understanding and deep knowledge in the game AI, like how it functions, how we are trying to, use multiple systems to work on in the gameplay, right? And what is the importance of AI? I think you guys know, right? The purpose of using an AI is not just creating a complex, but also making understand the believability of the world, right? We are making sure that the creatures or the characters or the game AI, right, will make us feel that we are in the particular world, right? First we need to understand the purpose of AI. Without understanding that, just like that, if you create an AI which actually behaves, which actually take a decision by itself without knowing any aspects, I think that won't work at all, right? So let's get deep dive into the actual topic, understanding what exactly the AI, game AI agent is, right? Game AI agent in game actually, which performs some intelligence with its behavior, right? So herely technically we'll use Unreal pawn or character which could be controlled by a controller, but understand it is actually the physical body in the world. That's what the AI agent that we create. So we'll start creating one by one. So for before continuing the topic, I just want to give a quick overview on project settings, like what I have been using. So I'm using a third person template, which comes with the Unreal template, right? So here you will also find out I'm using that a platformer 8 underworld. Currently you can grab it in fab, which is free for this month, and you can find out I'm trying to use the map called demonstration for my entire the AI execution area. This is the space which I'm trying to use. You'll find out that in the package called Platformer 8, you will find out in the map fab, and also you will find out a map called demonstration, which I'm trying to use that. If you're a game level designer, a platformer who tried to build a development part which you required a common a basic mesh, a level which is already existed, I think it's good to go. You can go and check it out. And second, here where I'm also trying to use a pack called stylized enemy NPC, out of which I have a lot of enemy characters, I mean NPC characters, where I could pick out from this particular package and try to use that one of as one of my NPC character. As well as I'm also trying to use an adventurous pack for a player. I will try to replace my third person character, right? So I want you to understand I'm not just using a mannequin, I'm just replacing the existed content with the character player or the enemy as well as the level, and try to use this entire project for the demonstration of game AI and how and what we are trying to discuss. Am I clear? Yes. So to get to that, let me create a separate folder, called it as game AI. Sorry, game AI PP. Okay, or else I'll collect all sort of elements which I created in this particular folder. So let me get to the blueprints. So here I have a third person character, the default character from third person template. So here I have replaced this particular character mesh with my existed uh, adventure character, which I'll downloaded from adventure pack. So you can use any of it. You can find out. Oh, I think this would fit. Yes, something like that. Yeah, you can select any character from the pack which you download, or else you can go with the mannequin itself. So I switched my skeletal mesh here. Also, this skeletal mesh is actually using the animation blueprint of this particular character. Let me check, save, minimize. Okay, let me add a player start. I think it's already in the outliner. Let me go through. Yes, make it direct towards that. Okay, yes, this is my player start. So let me play. Yes, this is how my character moving with its default animation blueprint. Okay, we are not going to deal with the animation blueprint, the characters mesh and its state machines, but today we will move forward with that. Yes, for the first step to create an AI, so I need to create AI agent first. As we already know, it's a physical body, right? So for that, I'll try to use the default mannequin, the template, the third person blueprint, right? So I will use the same character blueprint. I can create a new character blueprint. Also, I can create the use the existed character blueprint from here. So I'll duplicate that. I'm going to call this as pp enemy agent. You can see that. Let me move this particular agent to game AI folder. Okay, so I'll have all the structure over here, and you will find out. So this is a third person character, and let me go for okay, I moved my, sorry, my bad. Let me keep third person character in the same blueprint folder. I need to move my game enemy agent. Yes, so this is my enemy. You can see the viewport. So you can change your static mesh, go to the component here, and the right side in the mesh you will find out any static mesh. I think I have downloaded a package, the enemy NPC pack, which I already discussed, right? So I'll try to replace any one of the enemy package, yeah, animation. Let me look out which fit, sorry, which one goes fine for enemy, which you feel that this would work perfect. Okay, I want to replace an enemy agent, but um, I don't think I'm getting a lot of. You can use the default character as an enemy. I'll use this one. Yeah, as an enemy. Fine. Compile, save, minimize. See, now we have created actually a AI agent, right? Yeah, a physical body or an AI NPC character of a game. Okay, so let me drag and drop in any environment. I'll try to place it here. Oh, see, you can see this AI comes with a camera which we don't require. So take out the camera as well as the camera boom. Okay, delete this one and save it again. We don't require a perspective mode. So you can see that now we are with the empty character. Okay, and we have a player start here. When the game starts, okay, you will find out, okay, there is an AI enemy agent over there. So now we'll move forward. We'll start actually creating some stuff which how where the AI interacts, where the AI moves, where the AI actually follows, right? So we'll go step by step. To control an AI agent here, we are going to create a separate controller for that. Just like a player controllers that we have a separate AI controller as well. So we are going to create an AI controller, and that will actually controls a character, the controls an AI here. So let me get to the blueprint class. From here, from all classes, I'm going to go for select AI controller. What exactly the AI controller? Understand, AI controller is a kind of it's a brain which actually process and also controls the entire agent which we created, the AI agent which we created. I mean, simply to say, it actually decides what exactly agent should do. You got my point, right? It will possess the body, the entire AI body, what we created. It is a brain of a particular agent. So I'm going to create a controller. I'm going to say enemy. Okay, my bad. Enemy controller. Okay, you can rename as it is. Yeah, this is an enemy and this is an enemy controller. I need to assign this controller in this particular enemy. So for that, first we'll open enemy agent, and in class defaults, while selecting the root, you will select a pawn, and here make sure the auto process AI should be changed from place in world, because currently we actually place the AI in the world. Okay, that won't be the any problem. But what if you spawn with a code in the environment? Then there would be a problem. The AI won't work, the controller won't work. So for that, select place in world or spawn. Okay, and then in the AI controller class, you can actually choose uh, the default controller which I created right now. I mean, the enemy controller, attach that, compile, that's it. Okay, we just trying to say that we have a body and we have created a brain and we attach the brain to the body. That's it. Okay, this is what an AI controller is. But this brain should understand, should contain some decision making process system. Okay, this brain should we where we able to create a structure, right, a logic, a system where it should actually act according to the decision what we make, what it has, right? So here in the enemy controller, I am going to assign a separate behavior structure for this. Okay, before assigning, let me create an AI behavior tree. Okay, behavior tree is a decision making structure, which controls complete AI logic. There are many hierarchical node system that we work in this, right? As I said already, right? What this particular AI should do right now, you know, that's decision could be taken from this particular tree. It always run continuously. So before that, let us create a behavior tree here, and I'm going to call it as behavior tree of enemy. I can say enemy walk through, no, wander. Okay, so you can see I created a behavior tree. Not just you create, but also you need to assign this particular behavior tree in the controller. That's how it is connected. So let me open the controller. So here, let me add, sorry, in the event graph, you will find out event begin play. This is the place where I am going to add behavior tree. For that, let me use the node called run behavior tree. Okay. So here I'll try to add the behavior tree which I created. So that's how it's connected, right? You can see this controller contains a behavior tree which we created right now. Okay, let me open the behavior tree. You can see that. So here we are going to create a lot of logic, like there are ways where we can see like whether in an environment, the if the player has some path to wander, right? The player has some area where it could actually revolve around, right? And if it looks out the player, so that means it will check if the player is visible or not. Then directly it will move to the player. And when it finds out the player and when it nearby the player, it try to attack. Right? Not only that, it maybe sometimes will make our AI to patrol, right? To random different points from where we want to get inside. Let us assume any game that you played, there would be an AI that which has some targeted points over there. It will patrol from one to one randomly as well, right? So when the player is nearby, obviously the AI will try to follow, try to chase the particular player when it nearby, and it will go for the different decision, maybe the attack, maybe a friendly aspect, right? So that's kind of a logical tree that we are going to build in this particular behavior tree, right? So let's go and start creating a behavior tree. For this, we require a Blackboard asset. This is the place where we actually created decisions, right? Decision tree. But the point is that that decision tree should contain some memory, a data storage system. So we are going to understand a Blackboard. It is nothing but a data storage system used by the our behavior tree. It actually stores a lot of information, maybe the location, maybe the I can say maybe the placement of, or maybe any object, right? Maybe any conditions, maybe any, we'll use while creating a variables, right? We'll use n number of different properties, like if I want to calculate the player or enemy health to deal the damage, right? To understand the location of the player, to understand the location of the targeted points. So everything that we store in the Blackboard with the help of the variables. So let us create, let me save all, control shift yes to save all. Let me open, let me actually create a Blackboard from this. Okay, artificial intelligence. So this is Blackboard enemy, as I say. So this will look like this, and you can find out this Blackboard has some structure. You have a key and you have a Blackboard details as well. Whatever the key that we add, we can edit the parameters as well. So let me add a key. For example, if I want to change, if I want my AI to go around in a random location, location is nothing but which contains a direction X, Y, or Z, right? So for that, we are going to use a variable called vector. So enemy location, or okay, two, or else location would be better. The basic understanding. Yep. So here on the location type, make sure it should be vector and save, and come to your behavior tree. Here on the right side, make sure you have selected a Blackboard which you haven't created, which is Blackboard enemy, right? That's how we connecting the memory, the data storage of the behavior tree here. Now we start creating actually what is exactly the decision tree would works like. Clear? Yeah. So now understand, in the behavior tree we have a root and we have connected a bb enemy, which is a Blackboard. So if you drag this area, you will find out some composites, which is selector, sequence, and simple parallel. So we'll understand both these things, like what exactly is the selector, what exactly is the sequence, right? So the both has a different meaning in it, different structure in it, right? So we'll understand first what exactly the selector is, right? Selector is something, for example, if we connect a root to a skeleton, okay, whatever pass through this selector, it chooses first child. You know, there are many aspects that we follow with the selector, right? But the point is, it actually chooses the first child which succeed. Understand? Which actually becomes a true. For example, we'll understand like if there is a thing like we connected A, B, and C for the selector, right? And if the A works properly, if A becomes true, that means the selector won't pass to B and C. It will stop at that particular place. Right? That's how the selector works here. Let us understand deeper, like if the AI chases player, okay, and then it goes to petrol, and then it has a random wandering positions, whatever, right? So if the chasing of the player becomes true, if it contains a higher priority, that means it won't move to the petrol state. It will stop here. It will only concentrate on chasing the player, right? That's how the selector works, right? If the condition, if the this pass through becomes true, it won't follow up to the next. It will stop at the first position. It will stop at the condition which actually where actually it becomes true. But when we understand about the sequence here, it's quite opposite here, right? So here sequence will work like a step by step order. It actually executes the children, okay, and if one fails, and understand the entire sequence fails. Yes, what I'm trying to say that in the sequence, as I said in selector, if one becomes true, and it won't goes to the next step. But here in sequencer, if it is becomes true, it will move to the next part. But understand if it fails, right, the entire sequence will fails. So understand it will move from step by step process. So for example, let me conclude like first of all, it is checking the player is visible or not, right? And then if it is visible and then it becomes true, it will move to the player. And then once it moves to the player, it will understand the distance between the player and it will perform an animation, an action of attack or something, right? What if player is not visible? Obviously the sequence fails, right? Obviously when it comes to the selector of it try to go for the petrol, so sequence work like a completely a step by step logic. So now we'll understand working with the sequencer. So I created a sequencer, we rename it as like enemy vendor, okay. So here with the help of the sequencer I'm going to add a task. So before adding a task, I am going to create a new task from here. Okay. A task is something which actually performs an action, right? This is the place where we actually say the AI like to perform some action like move towards a location or wait for some time or play this particular sound, play this particular animation, right? And we'll set some values of the Blackboard memory, right? I mean, we will actually give a custom actions in this task system. So I'm going to create a task called as uh, move to random location. That is the name of my task. So here I'll try to add some code which where actually how the brain functions, right? This is where actually code exists. So let me add event receive execute AI, right? When this task execute, this AI task execute, and this is and the code that we are going to drop here is going to be execute, right? That's how the action part is going to be, structured here, right? So where event received execute AI, so when it is execute, I'm trying to move my AI, right? To move to a random location. For that, I'll try to use a node, right? Where we have a random navigable radius. We are going to get a random location in navigable radius. Navigable, right? I mean, our map should contain a nav mesh. We are going to add that, but understand this will work with the nav mesh only. And if you understand this part, what I'm trying to do when the AI, when we interacts with this particular task, it is moving to the random location. We need to say first what exactly the AI location. I want to get actor location. So before letting us to understand it is a random, first let me take the origin of the particular AI controlled upon. We are trying to get the actor location. This is my origin. And radius, I can promote it to the variable and make it to public, where I can edit my the radius of this particular location. Maybe the AI can only go random within its range about 1000 or 500 distance, right? So we can edit that later. And then this random location, right? We are trying to get the random location, but we're also going to set this location, right, in a blackboard. Here we are going to set this particular location in a blackboard. So let me switch to the task. Let me close this one. Yeah, and here I am going to use a node called set blackboard value. I'm going to set the blackboard value. Currently it was location, so I'm going to go for vector. So I'm going to connect this location over here. So I need a key. I need to assign a key. So which I already created in a memory in a Blackboard. If you remember, I created a location to assign that location, to attach that location. So for that I need to create a Blackboard key. So you can directly promote a key, promote a variable key here. So which should be Blackboard key selector. If you create one variable from here, you can go for Blackboard key selector. So I'm going to rename it as like location key or what. Yep. And let me compile, and now we'll finish the execution. Finish execute. So here what I'm trying to do, when the event receive execute AI, when this operates, you can see it actually taking the location of the AI and finding out the randomization within a range what we give. Okay, and then it is moving to the key, like which location that we are making to move forward, and it's completing its execution. And it won't work if you don't make this success true. So make sure this should be true. Compile. So we are done with the code part. We are done with the actual, random location. AI move to random location. That's how what we coded. Let me come to the behavior tree. So here let me connect the task. You can see I created a task called AI move to random location. This is my task. Okay, here on the right side you will find out. So let me control shift S, save all. Whatever you save, you should save all, right? So here on the right side you will find out radius. So I will give it something like around 1000 based on the enemy radius. It will move randomly only within this particular range. Okay, and there is one issue here you can find out. So you can see the radius here, but to assign a key, so we actually created a location key here, but we made a mistake, is that we actually didn't make it public. It should be instance editable. You can see that you can make it to true from here as well, right? It should be instance editable, then we can easily able to edit from here. On the right side you can see the location key is now on board. We can see, we can select the location, right? When the enemy wander, it is moving to the location, and it could be any random location from within this range. So here I am going to add move to. Okay, I'm trying to add another task, and I'm saying, telling that this particular code should work in a sequence, step 1 and step 2. You can see the sequence has an order in it. So here in this, I'm also going to select the Blackboard key called location, save, that's it. So we are trying to understand the behavior should work in such a way, it should pick a random location and move to the location. Okay, let me get and try to test out. So to test out, try to add a volume, okay, a blocking volume in a scene and which contains uh, the AI block. I think I already have that, right? Try to scale down whatever the area that you're working on. So I have added one of it here in navigable radius that we are using in the node, right? In the task system. So to actually work that to actually make the AI work, may I identify that its path in the environment, we are adding the volume called nav mesh bonds volume. So here, while selecting this, press P on the keyboard, so you will understand this is the area how the AI can actually able to move and work around. Understand there are gaps here, and that means it won't works on this area. It will only moves where the where we have a clean path here with the green in line, right? So let me switch on and off. Let me try it out. Before trying, actually, let me put my agent on board. Okay, I already have it. So let me play and test it out. I can see now player is spawned. If I move, okay, you can see the AI is moving. It's with its random location. I think we can find out the AI is moving its random location. It's not following the player. We haven't coded yet, but understand it's moving so fast. So to control that, let me open the behavior tree. Here I will add a node called wait. So here let me give a wait time something around 2 seconds and a random deviation if it is 1 second or something like that, because we need a randomization. Save and test it out. We'll wait for 3 seconds and move to the next step. You can see AI, okay, it wait for 3 seconds and move to the next step. And there is no near and far, it is going within the range of 1000. What we have been given, it's up to you how you actually give to your AI. So I think you're clear about like how we actually created the enemy wander system, like it's wandering randomly. Now it's a take to move to the next and advanced step of this particular part. See, we are going to create, now it's moving randomly. What if in such cases that we don't want the AI to move to certain locations? We have some fixed points. We have some restricted points where the AI need to move only that particular places. If you played any games, you can understand in stealth mode system, like the AI agents has some fixed points in a room so that they don't have that much of freedom, as well as they have a randomization on it from a fixed points. So we'll create that one right now. So to create that, so let me create a basic actor blueprint. Okay, so I'm going to call it as like for patrolling, for AI patrolling on a fixed point, I'm going to create patrol points. I'm going to call it as PP petrol points. Sorry, no special characters. Yes. So here there are two steps that I'm going to do. So I don't need this blueprint. I mean, is actually going to have some components of static mesh, but still I will add a component called sphere or any other shape just for for the visibility of understanding of where I'm placing this. So here I'll try to give some material, yeah, and making sure it has no collision. I don't want AI to interact this with this particular shape. I want this location of this particular route to be recorded, right? The point is the object is going to be recorded, the component is going to be recorded in the AI brain, right? So for that, I am going to take out the collision. I don't require any collision here, okay? And also, if possible, try to make sure okay, let me keep this as it is, compile. Okay, so let me switch, and you can see this is the point which I created. So what if I have a multiple point? multiple points, something like this. If I duplicate it like that, the AI will actually follow the target points which we haven't created. Okay, so it will move to the particular points, right? And if we want, we can make it to cycler. Also, if we want, we can actually go for the randomization. It's up to us, right? This is the particular points, only the place where the AI should detect its location and move towards the particular points. So step one, as we know, we created a basic petrol point here. That's how the AI is going to follow. Okay. For this, I will open, to understand, I will open a player, the agent, sorry, I will open the agent actually. No, this needs to understand the petrol points what we created. Okay, right now I created a separate petrol point, but this has to be understood, like what exactly the petrol point it is and why I'm using that and what's the purpose of this particular petrol point, right? So here what I'll try to do, I'll try to create a code, and in this code I'll try to communicate, right, whatever the AI controller that I have, right, and I'm going to control that particular point when patrolling. So first let us create a memory allocation here. Here I am going to create an object. I'm going to call it as target actor. Okay, make sure your key type should be object and the base class could be actor. So make sure your target actor would be actor. And second, I'm also creating a condition that it should move to the random points when it's in a state, in a true state of when it is patrolling. Okay. Oh my God. Let me add some spelling mistake structure. Yes. So it moves to the target actor when it is in patrolling state. Okay, you need to consider this particular action and then we'll get to the agent here. Okay, understand this enemy agent has a movement controls which we don't require that. Take out this particular part. See what I'm trying to communicate here, to count actually the petrol points. First I'll actually initiate that one. I will create event begin play. Okay, when the event begin play, so I'll try to cast to the controller, the enemy controller, because I want to call the Blackboard value which we created right now, the patrolling part, right? So for that I am going to use enemy controller cast node. You can see that, and then for this particular object I am going to give you know actually AI controller. I'm going to get an AI controller, and its controlled actor would be, sorry, let me go for, it should be self, because the agent is going to be get controlled. With the help of the controller, I am trying to, connect the AI, the enemy controller which I have been created. With the help of this, I'm going to get Blackboard. Okay. Also, I'm going to set Blackboard. So if it is a condition, you can use a boolean, right? If we are trying to understand a condition here. Yes, what exactly is the condition here? You can see uh, it is asking a name, right? To set the value as a bool. So I'll use make literal name. So here I'll use the same name which I used in the Blackboard. You can see on the Blackboard I use patrolling. Obviously we are working with the same name. No spelling mistake. You should be very careful, because if one's capital small spelling, if that won't works and this won't executes. So let me promote it variable. Again I'm going to rename it to is patrolling. Okay, here what I'm trying to communicate with the help of an enemy controller, I'm going to call the Blackboard and checking the condition. With the help of condition, I'm going to set the Blackboard value here, right? For this, to make the AI move from one point to another point, first of all, I need to create a function. So I'll create a function called cycle petrol points, a basic function. So this contains like for any I'm going to calculate the distance between, or else I'll calculate number of points that what I have. Based on that, what is the current point that the character is in, and it moves to the next point. Vice versa, it will actually shift to the all the points which is in the scene which we have been created. So for that, let me make instance readable. For that, I am going to create a variable current point. Okay, let me make it as integer, and then let me sorry let me create my bad another variable. This time I'm going to create a list of points, and which is with the reference of, I'm going to create give a reference for the petrol point which I created. Also, I'm actually going to change it to array, because we have a number of points and we are going to check from that. So I'll bring get list of points, okay, as well as get current point. Okay, from the list of points I'm going to go with length. So here I'm trying to check, and from its current point it's moving to the other one, the plus one. Sorry. And with this we'll actually check this current point is from the list of points. It's trying to check that, and then I'm going to set the current point right now. What I'm trying to communicate, so it's actually calculation is happening here. I think from the list of points, what exactly this current point is moving towards, right? That would be my current point. Then, and make sure the list of points, from the list of points, let me take the copy, because it's in array state, right? This would be my, the current point would be the next one, I mean move to the next one, right? So let me add a return one output, so I don't need this one. So let me connect, and the next point would be the reference one. So let me directly add to this one. Let me call it as next point. Okay, what it's trying to communicate, cycle of petrol points. Okay, you can see from this petrol points, you can see it's actually calculating the things here from the list of points. From it is actually checking the current point and trying to set the current point that would be your next point. Okay, that's how every time it's in a cycle process, it is moving towards different points again to the previous one, right? So let me save. Now this is the function what we created, but the point is to call this, actually we are going to create a separate behavior tree. I'll go and create separate behavior tree, called that as main, yes, AI main behavior tree, where I can able to communicate multiple aspects, like I could able to make the player chase, patrol, or any actions, any kind of a decisions, right? We can attach to this part here. This time I'm going with the selector. As I said, the child becomes true first, right? And then it succeeds. So here, with the help of selector, I am going to run the previous behavior tree. To do that, use run behavior tree. So I'm going to select the previous behavior tree, which is enemy vendor. Okay, I'm going to run the previous behavior tree here. Also, to make it continue, I will try to add a sequence. And this is the place where I am making my AI agent petrol. Right, so this would be the petrol state, and this is in a sequence because we have a many path to go. Like we have a many steps to actually add it in the petroling so that it will move towards the particular location. For that, first of all, make sure you have added a target actor here, and that should be actor. Right, this should be should. And second, uh, for to connect a petrol point to make it cycle, you need to actually create a task for the cycling petrol. So for that, I'll create a task based on blueprint base, cycle points. Okay. So here from the function event receive execute AI, I'll override this with, and then I need to call the function which is already created in the enemy agent. Right? To call that first, I'm trying to use a cast node here. Cast to enemy agent. Go for enemy agent. Okay, controlled upon is your agent. And now I'm going to connect the cycle petrol points which already created from the enemy agent. And this time I am going to set the blackboard value. Set blackboard value as object. I am trying to move the AI to move to the target point, which is an actor, as we took it as an object here. Okay, this is my next point, and I will promote it to a variable. I'm calling it as target point. And make sure this target point would be a Blackboard key selector. Okay, and make should be it should be instance editable. Compile. So what we are trying to communicate here, I'm trying to again execute AI. With the help of that, I'm going to call the function cycle petrol points, which I created in enemy agent. And then to move it to the next point, I'm making sure my AI to perform this task by setting up a Blackboard key here, which is target actor. And let me finish the code. I think you got the point, right? So here, make sure it should be success. Okay, task is cycle petrol points. Compile. Now, so we know that this is how we create a task, but to connect that, open your actual petrol sequence which you created right now. Let me connect a task. Task name is task cycle points. So make sure your target point is set to here. The target point is set to target actor. Okay, we are making sure to get to the target point. Also, I'll use another task which is move to. Make sure this is also to be set to target actor. Okay, and let me create a wait. This is exactly how we created the sequence uh, from the previous part. But there is a difference here. So I have connected the sequence in the selector. So how this behavior tree should understand to select this particular part. This condition may fails, it will move to the next one, right? So to make it true, to make it understand that when it become true, to execute this one. So how could I able to make the condition true? We need to add a if conditions, right? To add such kind of things, I already said that we are going to understand about decorators, right? A decorator will work like where we could able to choose a condition here, right? To do that, let me add a decorator from here, right? And let me add a condition in a Blackboard based condition. Use a Blackboard based condition here. With the help of the Blackboard, you can actually use this following, like is set is not set. When it is set to patrolling, is not set to patrolling. So that's how you can able to calculate the Blackboard based conditions. And I'm going to choose a condition which is called as patrolling. Compile, save. Okay, and now I think we are set to test right now. Okay, save and minimize. Let me check play. You can see the enemy moving random, but not the target point, the petrol points. There is one more step I think we have missed. So select your AI first. So here, with the help of selecting the AI, try to search for petrol. Make sure this to be true. Also, uh, search for the point which we created, the list of points which we created in the AI agent, right? It should be instance editable to see here. And let me go for adding array elements here, and let me go for select your point 1. I'll select point 2. I'll select point 3 and also go for point 4. So that's how and what we are going to do that. Play and check it out. Like, is it working? No, no, it's not working. So let us check. Open your main tree. Okay, you can do that while playing. You can understand like whether how the key functioning. So let me get to the condition here. You can see, you can pause the code, you can resume it, you can stop, right? And you can actually see the condition is working or not. Directly you can see it's not into this condition at all. Actually you can see this is not calling at all, right? Let me stop and minimize. Oh, I got it. The reason behind that is like I think you are calling the behavior tree in a controller, in an enemy controller, right? So let me open the enemy controller. You can see the behavior tree I'm calling is the previous one, not the right current one. Open that, compile, and now test it out. Play. Hope so. It should pick up target point. Okay, it picked up this one. Cool. It picked up next one. Cool. Yes, and it also picked up the third one. You can see it's cycling the petrol points here. And the fourth one, it depends on how what order you have given. Also, you can randomize the order as well with the code, right? So currently, it is using that based on the sequence that you ordered. It's cycling the petrol points. You can see in many games, I think this would work. This how we can control. We cannot make an AI to follow every space. I think this is one of the optimization method in a mobile games, especially giving a fixed point. Because if you don't give the fixed point randomly, if it follows, if it chases, if it moves, obviously the performance will lag, right? So that's how you need to understand why we are using this method. And not only that, let us understand the code first. With the help of selector, if this become true and it's not moving to random. In the previous session we have been observed that if this won't calls, if it fails, it goes to the random behavior. No target points could be picked up. But if it is actually becomes true, it will stick to this particular point. So that's how we actually calculated the condition, the patrolling. Now, moving forward, we'll go for the chasing as well, right? This is the patrolling state that what we worked further. Right now, we'll go for the different part, which is a chasing. So for that, let me add a Blackboard key, a condition. I need to check is chasing. Okay. Also, the same thing I need to go as I selected the Blackboard sequence here. I am also going to create another sequence. Okay, calling it as a chasing or something. Okay. Yes, this time, for the chasing part, I am going to create a service. Till now, I created a called a task system. Right now, I'm going to create a service. Service will run every point second in a frame. It will keep on continuing. It will keep on checking. Right? Chasing is something like when the player is visible, it moves to the chasing mode, right? And when it travels to the chasing mode, that means it should run the code for every point second, 0.5 second, right? So you need to be make sure if it is not checking every time, it will only check when the game starts, and if the player is visible, also it won't check because the code runs only one time. But this by using service, we can do that continuously. So let me create new service. I'm going to call it as I'm going to call it as yes, let me call it as chasing, no space, chasing the player. Okay, and then in this, so I'm going to go do some code. So as a function, I'm going to use this time event receive tick AI, because we are going to call it every 0.5 second, right? So I'm going to use event tick AI. Okay, so I need to check the distance between player and the distance between the AI. So to check the distance, first of all, this is an AI. So I am going to get, sorry, from the control pawn, I am going to get actor location. Okay, also I'm going to get the player location as well. For that, I'm calling player pawn, as well as get player location. Sorry, get location, get actor location. So I'm going to check the distance. Okay, and this time, if it is, if the distance is less than some value, the radius or whatever, 500, if distance is less than 500 or 1000, right? Then the condition become true, and based on true condition, we need to, make a target to follow something. In a false state, also we need to understand the target to follow something. So what I'll do, I'll add a branch node as we do in the code. Like you can see, every 0.5 second it is checking the distance here, distance of the actor and an AI. And now here in this part, I am going to set a, a Blackboard value. This time we are using a condition, right? So I'm going to use a Blackboard value as a bool. Okay. If it is become true, I am going to set it to true. Right? Let me duplicate. If it is become false, I'm going to make the condition is going to false. And when it is false, we need to assign a Blackboard value, right? So let me promote to variable. I'm going to call like chasing Blackboard, chasing Blackboard value. Oh God, chasing. Let me make it to promote, and I can connect the same to this false note as well. right? When the distance is not true, the condition is becoming false. When distance is true, and you can see the condition is becoming true, right? And what happens when it becomes true? Again, I will again use the set Blackboard value as an object. Okay, so from this I'm going to create another variable. I'm going to call it as chase target, and make it to true. And let me get player pawn. I mean, see here, I need to get the player pawn because I'm going to chase the target to what? To the target to get player pawn. Okay, so understand if the condition is becoming true, it is moving towards the player. Simple. And if the distance is far, again the condition fails and it will move to the next sequence. So that's what we are trying to communicate with this service. So here, player, sorry, AI chase player with. There are many formats that we follow. This time we are doing with the distance part. Okay, so we'll connect that service in chasing. So let me add a service. Okay, and the service which we created chase the player. Oh my god, spelling mistake. Let me switch to proper renaming thing. Okay, I'll do that. Chasing BB value. Yeah. So you can see BT service chasing. I created this one. Chasing the player. Okay. So I need to make the condition is set to true or false. For that, again, I am going to add a decorator called Blackboard, and here I am going to set. This time I am going to use set if it is chasing. I can also choose the priority here, like I'll choose less priority when it only detects when the distance part, right? So it's chasing, and when it is chasing, also make sure there should be a Blackboard value. So first of all, understand this part. So I'm trying to chase the Blackboard value and chase the target, right? Understand this part. And based on that, I'll try to connect this particular chasing. You can see that we need to say the code that the Blackboard value should be chasing. The condition is going to become true, as well as target would be the target actor. When it pass, when it fails, this is what we are trying to use that, right? When it is set, this is what we are going to connect that, right? So this is what, and then we'll go to MoveTo, and this time I'm going to go for target actor. Okay, this is a target actor what we have. Yes, let us understand what's happening here. It is checking the condition. If it is in chasing mode, it is going to the service what we have been worked on, and here it's trying to check the distance and try to behave according to the condition, whether it was true, whether it was false, and then it is moving to the target actor if it is based on the condition. Okay, so let me try once whether it's working or not. Play. Okay, you can check that it's moving. I'm at the distance 500. Okay, it's not. Okay, let me check the condition true or false. But right now I'm just understanding. Yeah, it's not. Let me check. You open the blueprint. Okay, this is my cycle points. It's checking the condition. Okay, yes. So I can check in the main condition. It's directly moving to the petrol when it's becoming false. So let me get this added here. So overall, every time it is checking the chasing part, and then it is moving to the target actor. Let me play. Okay, let me check. It's moving to the target point. Yes, you are at the distance of 500, it's chasing to you. When you are out of distance, let me go out of from this. Yes, you can see you're out of it, and it will you're out of it's trying to communicate you. You're make sure you're more than 500. Yeah, it will follow the default patrolling points. You can observe that. When it is out of range, the AI is following the default patrol point. And when you are in this particular range, it is trying to follow you. It will try to follow you. Yeah, it will actually calculate the distance and come towards you. Right? That's how you can create a smart AI based on the decision making, not just a follow. You can add an attack, a behavior. You can add a different structure. You can add a distance behavior by using the same similar logic method. The code what you perform in task and the services which actually define how you make your AI more smarter. So this is the process like how the AI will works and make sure your code should communicate what you're trying to add it here and make sure like how the conditions are working and let us quickly go with the process like what we have been discussed till now. Okay, so first of all, we created a separate agent with the help of third person character. Okay, and then in this agent I cleared all the code which is existed and the camera which is existed, right? And I have been assigned a pawn here which is a player controller, as you can see, sorry, AI controller here in the AI controller class which I created enemy controller. And then I also make sure like if it is pawn also this should work. Okay, and then I connected I created an AI controller which is named enemy controller here, and you can see I called a run behavior tree, right? And the behavior which I created, first of all I created a basic vendor behavior with the help of sequence. You can see there is a distance that is moving towards, right? And for the distance we created a task, and here we are communicating a random location movement for an AI. Okay, and after that we went to the actual creating a points. For that I created a basic petrol point, actor blueprint which is has no collision. Also I can make this hidden in game because I don't want to see. To just preview that would be okay, but to not to see in the game, then that won't work. So you can actually connect that. And third, what you can do, you can actually get to the we already done the next step is about creating the actual blueprint in the agent here. In the event graph, we communicated to bring the Blackboard and set its the Boolean condition here, which is patrolling. And not only that, we also created a function. Okay, and here we are trying to communicate like based on its current petrol point it should move to the next petrol point, and based on how many petrol points we have in the list here, so sequentially it is moving step by step to the next petrol point every time, right? So that's how we created a function here. So to use this function I actually created a separate behavior tree called btai main. So here you can see you have a behavior tree and you have a basic root system. Here I had a selector. As I said, the child becomes true first and then later. So you can see if the child becomes true, if the chasing becomes true, it will stick to this point. It won't move to the petrol and the other aspects. If this fails, it will move to the patrolling state, right? That's how it works. So in this I connected the previous behavior system, the vendor behavior system here. It's up to you. Do you want to connect it or not based on the execution that you require? And then I created a sequence, and in this sequence, I added a Blackboard based condition where I am connecting my condition here, whether it's set to patrolling or is not set to patrolling. It's upon us. And next, we created a task for the cycle patrolling. So in this task, what we are trying to communicate, we are trying to connect the cycle petrol point, which we created a function in agent enemy, right? I'm trying to give an next target point of this particular object, right? Every time when it moves to the next point, it need to pick the next object, right? It should perform a task in the brain of an AI. That is what we are communicating in this particular task. Okay, and after that we connected it to target actor and move towards the target, and we waited, make him wait for some time, and then I created a separate sequence again. I set separate sequence called chasing, and again I moved it to the target, but this time I selected a condition is set to chasing when the AI is set to chasing, and this is what it moves forward. So this time, not the task. This time I tried to create a service because this works. We need to make the player works every fraction of seconds, right? So for that, I created a service. So in this service, I am checking every 0.5 second that the distance of the AI and the distance of the player is less than or this one. And if this condition is becoming true, I'm making sure it move towards the player. If the condition is false, I'm making the value is false. That means chasing is becoming false here, chasing is becoming true here. If the chasing is false, obviously it will transfer to the patrolling states. So I connected the service directly on the selector because it won't wait for the order here. It directly communicate if the chase is not true, directly it will move towards the respective condition here, like target actor when it is not chasing or chasing, right? So that's how we did that. And when we play, you can see that the AI is actually moving towards the petrol points. The objects are invisible right now. Now when he is nearby, I kept it very low, which is 500. You can see no AI follows the player. It doesn't matter how, if you're out of boundary, obviously it will follow the previous petrol point and try to connect to the cycle which you have been created. You can also choose the same petrol points into random as well. Okay, this is what we try to do in a particular session. So if you have any queries, if you have any issues, just ping me right now, ping me in the comment section over there, and I hope you got the point, everything what we try to communicate. Yes, if any questions, just let us know. Yeah, thank you guys, thank you so much, and thank you for being with me.